As many of you probably figured out right now, I'm not Stacy Curry, but my mustache is way better. Stacy called me. I'm her advisor. She emailed me last night and said she was sick and could not attend. I don't know, I have my doubts, but anyway, I told her I would fill in, and so she sent me two sort of things she was working on, late. So I've put them together. I'll do the best I can. I'll try to be brief so we can go on to other things. If you want to ask questions afterwards, I'll be happy to answer them. Anything I can't answer about her work, I'll add another chapter onto her dissertation and send it to her with your compliments. But basically, what we've done is we've been looking at a series of historic sites throughout North Carolina and trying to figure out how best to model them in a 3D cloud. And today we're going to talk about two of the sites, one at Guilford Courthouse National Battlefield and one at the Alston House. The Guilford Courthouse National Battlefield, I'm sure all of you are aware, was a colonial battle between the British and the colonial army with a bunch of militia and reserve. And it's the Alston House, or also known as the House in the Horseshoe, is a nice little place. It's there was a skirmish between the sort of the back country between the Loyalists and the Tories, and the house is still there and it has a bunch of bullet holes in it. You can go look at the bullet holes in it and look at it. So the first one, so we're trying to combine a bunch of different data. A lot of her dissertation is in combining different kinds of data together into a single visualized product. So the Guilford Courthouse, 18th century battle. So we got a little pointer up here. It's the battlefield. What happened is the British Army advanced from this way, came across, and General Greene set his army up in three lines. We know where the first two lines are really well. The third line, or the pivotal line, kind of disappeared and got lost over time. It's been mapped anywhere around these areas. So we did some work at the traditional location of that area, and we wanted to see if we could find, because their scholars are always discussing the retreat road, which is where when General Greene had his flank turned by the British, Cornwallis, he retreated north up to the ironworks up in Rockingham County. There's an old retreat road there. They also talk about a gully where Colonel Washington, actually, General Washington's nephew led a cavalry charge, and there's records of him leaping a gully. Well, during our research there, we found what is a gully or a road. It was a swell in the surface, and we dug down to it. It had been filled, and we just kept digging down into it, lower. We hit a surface. We punched a hole in this rock sort of covered surface, and we found prehistoric colonial artifacts with a buck and ball and some other implements that we know. So we know that's period. We know that we got the right time period. So on the surface of it, what we have then is we wanted to look at the GPR data. That's how we found this whole thing. We found the subsurface using GPR, and then it disappears down into the woods. And GPR sends a radio wave down into the ground. Any change within that ground surface will get recorded. So if all the surface is the same going down, you don't see any change. If you hit change, it gives you a reading. So we found the whole road. We mapped it out. It runs right down through here and out with the GPR into the woods. So then we took it, and since it comes out as sort of an analog wave, you can cut slices of it and make either a profile view of it or a flat surface view of it, like a plan view of it. But what we wanted to do, since we were going to bring in some LiDAR, terrestrial LiDAR, is turn it into a point cloud. So they put it into Voxel 3, and we tried to turn that into a point cloud, and we did it in like tenths of like about every 10 centimeters or 5 centimeters down through the surface, so we could generate a cloud that sort of went and created like a 3D data cube, just like you heard about with your LiDAR cloud. So that's what we were trying to get with that. Then we brought in the terrestrial scanner, some friends of ours from Auburn, because we do not have one of those, which I wish we did. So if anybody wants to donate to the University of Greensboro Geography Department LiDAR, let me know. I'll be glad to take your name and chat with you. So we went out and we spun the LiDAR because it was our hopes we could get the swale with that LiDAR out in the open really well. But when it went into the woods, the GPR can't penetrate through the roots underneath all the trees. It just breaks up and says, well, yeah, there's lots of stuff under here. It doesn't differentiate, so we just couldn't see it. So then we said, well, okay, maybe the LiDAR, maybe that swale will go down through the woods and we can get it with LiDAR, and then we can try to marry the two products together. So that's sort of like the bigger area with that. That's the LiDAR. We ran with that, and then that's where she overlaid those two, and we're trying to bring the whole thing up from below ground surface, and above ground. It worked fairly well for us, like I said, in the open, but I don't think we collected enough data to get it as closely as we wanted in the woods. We did it leaf off. There's always leaf litter there. So we worked with that method on it. So we used Ray-Dan, Voxler software. Our little computers took a long time to process a lot of these little LiDAR images and everything else, because it was a lot of data that my little lab computers weren't that accustomed to seeing shipped at them in one method. So our next adventure was to try to do some low-cost 3D. LiDAR is expensive and high cost, and we want to do low-cost 3D, so we went to the house in the Horseshoe, or the Alston house. It's located down near Sanford, North Carolina. With a skirmish between there. You can't see the bullet holes in there, but there are little bullet holes in there, and you can go down there. It's a state historic site. They let us come down there. We originally invited down there to run our radar. They were trying to find outbuildings, different things like that, where the kitchen was, which is all gone now, and other subsurface anomalies. So we were out there doing the radar, and so then we decided, well, let's take a bunch of pictures and try to create a 3D model of that with just basically a single lens reflex camera, taking a whole bunch of pictures, over 125 pictures around this, and then just using sort of one very inexpensive and one free software package. So we use a VisualSFM, which is just online. It's a shareware to put all the data in. And then the other one was a Photoscan, AGI Photoscan. It's fairly inexpensive for universities. We put those in. They'll use the same algorithm. We had a total of 124 pictures, and we took a lot of the pictures trying to get up their shrubs around the house. So you try to get in between them in different views of that to see what you can get. The results from the VisualSFM, they were pretty good. It's all free, so that's really nice. We had some real problems on the roof creating it because the camera just didn't get enough imagery, or didn't get enough clear imagery up on the roof, and sort of way in the front. We wanted to have a UAV out there, and actually we early on, before they set a lot of the regulations for UAV, when I was just in the session on UAVs, we were going to put one up there, and then they started regulating and said, no, you can't do that. So we're going to try to revisit that because we're licensed now. We have students that have taken their test, and we're going to try to put a UAV up if the state will let us. So what happens is, in the structure from motion, it goes and tries to pick the same points in every single case. So it will look at the different angles, and it will try to say, well, these are all the same place on this house at different angles, and then it constructs a 3D model which will rotate, and this one doesn't rotate, but you can see the roof really breaks apart. Down here breaks apart. You can see some of the remnants of trees, bushes. That's not a bush or a planter on that house. It's just couldn't get rid of it on there. So it did a fairly good job. You can rotate it, look at all three sides of the house. And then the AGA Photosoft, it did in some ways a lot better. It's clearer right in here, but it really got wanky right out in there and tore it up. And I'm not sure exactly why it really broke apart more so there than it did other places, but it created a pretty good image. Our processing time then was a problem for us. Computers weren't that great. Software format and further testing. So what we've been doing next. So several things she has moved on to, which I'll just go ahead and mention real quickly, is we did get a total LiDAR station, a terrestrial LiDAR out there. Some other friends of ours donated their time, and they brought the LiDAR, and we've spun the whole LiDAR on it. We're using a CAD system now to go back in with our pictures, and we're looking at the pictures, and instead of just putting it in this package and creating a 3D model, the CAD system actually lets us go in and set points. So we have a couple of points that when we did the initial work, we took a total station and just mapped sort of the edges of the house, because we didn't think we were going to need much more than that, just to show where it was and all that. But the CAD is letting us come in and place points and say these 2 points are so far apart. Then we're using triangulation to go in and set more points, and we're cleaning up the 3D version of what we did, and we're beginning to compare it to the total, to the LiDAR, because the LiDAR, it's light ranging, and it's perfect when it hits there. So we're cleaning up the points to see how well it can then create a real inexpensive 3D model, and secondly, how accurate that 3D model is. Because as you can expect right now, our accuracy is with the LiDAR, and we're trying to start matching that. So the great things about the digital camera, though, are they're low cost, software is free, you can do some really nice work with it, and I've found just playing with it, smaller stuff it works a lot better with than bigger stuff. You can get really good photo stand and camera and take a picture all the way around. So we're looking at spatial accuracy in that. And this is I'll just run through these really quick. There's no big deal. This is some of the initial, the guy just sort of sent it back to us. So these are the initial products we're getting back from the total station LiDAR that shot the thing. We even got inside the house. They claim the state doesn't claim it, but other people have said the Alston house is haunted, and that kind of does look a little spooky to me. But anyway, you're seeing, it's interesting, some of the waves in here, that does need cleaning up. That banister is a little wonky, but not that bad. And just the house pictures. You can see some of the shrubbery and the handicap ramp. We were trying to take those things off to just show the historic house. We were doing that. And then the area around it, the trees, the shrubs, and Mr. Austin. So anyway, I will stop with that so we can move on to our other students. Do you have any questions, or I'll be happy to answer what I can. Okay, good.